Okay, so we are going to be rewriting absolute value functions as piecewise defined functions. So kind of the reverse of what we were doing before, where we were given a piecewise function and we came up with a graph. Now we're going to take something and we're going to make it into a piecewise function. So they've given us the equation here, f of x equals absolute value of 2x plus 4 minus 3. And they've asked us to sketch the graph using what we knew about from Algebra 2. So we're going graphing first. Now, one thing I wanted to remind you from Algebra 2, when we did transformations, they looked like this. The a value, which is your vertical stretch, and then we had the b, and then in parentheses we had x minus c plus d. And that applied to any transformation that we might use. The reason that I want to point that out is, in this case, there's no parentheses separating this, which means that your b value, whatever it might be, has already been distributed. So because of that, for this function, I'm going to have to factor out, or kind of undistribute it, in order to determine my vertex. So when I do that, this 2, which is obviously my b value, has to be factored out of both pieces here. So I end up with my absolute value being f of x equals the absolute value of 2, and in parentheses, x plus 2 minus 3. And when I do it that way, I can see my vertex. And if you remember, I know we didn't do a lot with absolute value in Algebra 2, but finding the vertex of an absolute value function is very similar to finding the vertex of a quadratic. So you can just take these two and remember, if it's inside with x, it's actually the opposite piece, so your vertex ends up being the point -2, -3. Okay, so I am going to go over to -2, -3 and put a dot. That's my vertex. Now this value, because it's grouped with x, that's a horizontal compression, which is also going to look a lot like a vertical stretch. It's kind of like a slope. So I know I'm going up 2 over 1. And that would be in both directions because this is an absolute value. So I can put those, and then if you have a straight edge, you can draw it with a straight edge. You don't have to be perfect here, but it would look like this. Like a V. So there's my absolute value function based on what I remember from Algebra 2. So if I'm looking at those pieces, and I want to write the equation of each piece, I have to identify what shape they are. Well, absolute values are easy. They are linear. So I have this linear piece, the one on the right-hand side, and I have this linear piece, the one on the left-hand side. So let's first define our constraints. I have this linear piece, if I'm reading from left to right, I have this linear piece, and it goes as far as this place right here, and then it switches to a different linear piece. So from -infinity all the way to -2, or where x is less than or equal to -2. And then right there at -2, it switches behavior. It's still linear, but it's a different line. So from x is greater than or equal to -2, I have a different line. So now let's define what the lines are. Now I'm going to define this one first, even though it's the right-hand piece, the one on the bottom, because it's the easiest. Because I can see my slope, if I'm going to use slope-intercept, I can see my y-intercept right there is +1. I already know my slope because I counted it a minute ago. So my equation down here is 2x plus 1. Then if I want the equation of this line, I can't see my y-intercept, but knowing that my slope was, in this case, -2, I go down 2 over 1, and down 2 over 1 would get me to my y-intercept. So that would be -7. So this piece is going to be -2x minus 7. Now we did that all based on what we knew from Algebra 2. What we want to do now is figure out, is there a way, and there is, to come up with these equations without graphing it, and without having to count the slope and everything else. So this is the process by which we're going to do that. So your first step is to set each expression inside of the absolute value equal to 0 and solve for x. So the piece that was inside the absolute value, that's this, set it equal to 0 and solve for x. So I'm just going to do that real quick. So I get x equals, in this case, -2. Now the next step tells me to draw a number line and divide it into intervals. So here's my number line. Using the x value that I found. So using this, I'm going to put that on this number line. And I've now divided my number line into two separate pieces. Now it says write the entire equation of the function in each interval. So this is an interval from -∞ to -2. So write the entire equation there, replacing the absolute value bars with parentheses. So I'm going to write this as 2x plus 4 minus 3. And I'm going to do the same thing here, because this is another interval. This is from 2 to infinity. Now, moving on to step 3, it says determine the sign of each expression. So I have two expressions here. I'm going to have to determine the sign of each expression by choosing a value from each interval and substituting that value in for x. Well, my interval here, my first interval, I said was -∞ to -2. So I can choose any value inside of that interval and plug it into this expression. So I'm just going to use -3 because that's the first one that comes to mind. So I'm going to plug in -2 times -3. Oh, I'm sorry, not negative. It's not negative. Excuse me. I'm using this equation here. So it's 2x plus 4. So 2 times -3 plus 4 minus 3. And then I'm just going to simplify that. So that would be -6 plus 4, which comes out to be -2. Now that means that this expression, this entire expression, the one that's over here on this side, is negative. So I am going to make the expression negative by putting a negative sign in front of the expression. Now I've got to do the same thing for the other interval. So let's do that. So I'm going to do -2 to infinity, and you can choose any value you want. In this case, I'm going to use 0, because that's a nice, easy one. So 2 times 0 plus 4 minus 3. And that would be 4 minus 3, which comes out to be 1, which is, in fact, positive. Which means this side, the expression is positive. So this side ends up being negative, and this side ends up being positive. So now here I'm going to simplify each of those equations by distributing the signs. So up here, I have that negative in front of the expression. I'm going to distribute it to both pieces. Now I stop right there because of that parentheses. So it ends up being -2x minus 4, and the -3 stays the same. Combine like terms, and you end up with -2x minus 7. I'm going to do the same thing for the second one. It was positive up here, so I can just distribute the positive, 2x plus 4 minus 3, which becomes 2x plus 1. Now this piece was for the interval -∞ to -2, and this piece was from -2 to infinity. Now if you look at what we've just done, we have just come up with the exact same equations, this and this, as we got up here. And that we did without graphing. So let's do another one on the next page without graphing it first. So we're just going to go step by step like we just did. So I've got each expression. Now in this case there are two of them, but it says each expression gets set equal to 0. So I have x plus 4 equals 0, and x minus 1 equals 0. So x equals -4, and x equals 1. Now the next step tells me exactly what to do. Draw a number line and divide it into intervals. This time I have more than 1 that are going to go on my number line. So I've got -4 and 1, which means I have 3 intervals this time. I need to rewrite the expression in all 3 places, taking off the bars and putting instead parentheses. So I'm going to have on the left x plus 4 plus x minus 1. In the middle, x plus 4 plus x minus 1. And on the right-hand side, x plus 4 plus x minus 1. Now we move down to number 3. I need to determine the sign of each expression in the parentheses by choosing a value from each interval. And there are 3 this time. So I'm going to do the first one, the left-hand side, that's negative infinity to negative 4. You can choose any number that is between negative infinity and negative 4. So just because it's the closest one, I am going to use negative 5. So I'm plugging that in, negative 5 plus 4 plus negative 5 minus 1. In this case, negative 5 plus 4 is negative 1. Negative 5, negative 6 is negative 6. They are both expressions come out to be negative. So in this case, I'm going to go up to my number line, and both expressions become negative. Now we've got to do the same thing for the middle piece. So this is negative 4 to 1. This is the easy one because 0's in there. So I'm going to plug in 0 plus 4 plus 0 minus 1. Well, that's 4 plus negative 1. Now in this case, the first expression is positive and the second one comes out negative. So up here on my number line, my first expression gets a negative sign, but my second expression remains positive. Now we've got to do the last interval, so from 1 to infinity, and I'll just use 2. So 2 plus 4, which is positive, that's 6, plus 2 minus 1, that is also positive, because that's 1. So both of these are positive, positive, positive. All right, so now, simplifying the equation. So I'm going to distribute the negative up here. That's going to give me negative x minus 4. Distribute this negative, minus x minus 1, which simplifies to negative 2x minus 5. That's from the interval negative infinity to negative 4. Then my middle interval, I distribute the negative. Get negative x minus 4 plus x minus 1. Simplify that, and look what happens. My x's cancel out, and I end up with negative, is that negative 5? Yep, looks like negative 5. And that is from the interval negative 4 to 1. And then my last equation, I have positive, positive, so it comes out to be x plus 4 plus x minus 1. So when you add that, you get 2x plus 3, and that's the interval from 1 to infinity. I'm looking at my middle equation. Negative x minus 4. I guess that's right. Okay, so now when I look at this, I've got two, it's actually all lines, but what kind of line is this middle piece? That middle line is going to give you a constant. So the first thing, and I would say that that would be the easiest piece to graph, although I can't figure out why it's negative, because when I did this earlier, it came out to be positive 5. So let me look real quick at the one I did earlier today and see what mistake I've made. Oh, I see what I did. I wrote this backwards. This is where my negative is, and this is where my positive is, and I wrote them backwards. I'm so sorry. Plus, negative. So sorry. So that means this is going to be plus x plus 4 minus x plus 1, which makes this positive 5. I am so sorry. Hope I just didn't confuse the heck out of you guys just then. But up here, see what I did? I wrote the signs backwards, but this one is the negative 1 piece. Okay, so now let's graph this. And I'm going to go ahead and graph the constant piece, because this is the horizontal line. So between negative 4 and 1, I'm at the constant 5. So I've got negative 4 and 1. And it's a constant line, a straight line like this. Then after that, I know that I have got a negative slope on this side. It would cross at negative 5, but really I could just go up 2 over 1, up 2 over 1. I know that this piece is going to infinity that way. This piece is going up 2 over 1, up 2 over 1, infinity this way. So it looks like that. When we get down to the bottom, my domain would be negative infinity to positive infinity. How far left and how far right. And then your range, remember, it's how far down to how far up. So that would be bracket 5 to infinity, because there's actually a place at 5. All right, so that's the process. I want you, for your assignment, I want you to complete number 1 and number 2, just like that. If you'll follow the steps in your notes and operate just like that, you shouldn't have any trouble.